You know, this social distancing thing isn't that bad. I mean, when I was in high school, every girl I knew stayed more than 6 feet away from me. Earlier, you guys voted on what my wardrobe theme should be for week 4. It was a close race again, but you guys voted for monochrome for coronavirus. So, what I'm doing here is I'm wearing all the same color. Everything I'm wearing is just a different shade of red. We're starting a new unit this week, and we're moving on from the basics about atoms and things like that to talking more about the periodic table. The periodic table is a weird shape, and by the end of this unit, I'm hoping that you're going to be able to know why the periodic table is shaped the way that it is, and how much information is really stored in that periodic table, more than you realized before. So today is just going to be a brief introduction to the periodic table, and we're going to go over some basics that you probably learned a little bit about in middle school, but we need to touch on these things again before we move on and get into some deeper stuff. So here what we're going to do is we're going to talk about the periodic table, and if you've ever seen the periodic table, you'll notice that it's a very odd shape. It's not a perfect square, it's not a rectangle, it has this very sort of odd shape where some columns are taller than the others and some rows kind of skip a bunch of things and they have a bunch of blank areas and things like that. By the end of this unit, I hope that you have a pretty good understanding of why the table is shaped the way that it is. And the reason why it's shaped the way it is to convey information. And so there's a ton of information in the periodic table that you don't even know about yet because you haven't been taught it. So as kind of an example, I have this set of cards here. So I have a set of cards here, and the question is, what are the patterns that you can see? Take a look at how these cards are arranged. You can write this down if you want, but take a couple of seconds. You can pause the video if you need to. What patterns do you see in the arrangement of these cards? So this isn't too hard, but if you're observant, you'll see that all the rows have the same shape, right? The first row is a square, the second row is a triangle, so on and so forth, right? You'll also see that the columns are all the same color, right? And also you'll notice that they have numbers on them, and these cards are numbered in order of the top number, right? It goes 1, if we look at the top number here, it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth, right? And so once you get these patterns, you could make like if one of these cards was missing, you could make a prediction about what it looks like, right? Like let's say this card right here were missing. I'm going to kind of, right, imagine that it were missing. If it were missing, you would be able to predict what would go there. You would say, well, it's probably going to be green. It will probably have a top number of 15, and it'll probably be a circle, right? And you can deduce that information purely based on the patterns that you see. And so the reason why I show you that is that this is really a simplified version of the periodic table. Now, before we get too much into the periodic table, I want to talk about who is responsible for inventing it. So the guy who invented the periodic table was a Russian scientist named Dmitry Mendeleev, right? So he was Russian. He certainly looks Russian. He was alive probably in the mid-1800s, mid to late 1800s. And the story about how he came up with the periodic table is actually a pretty cool one. It's actually something that you might see in a movie or something like that. What ended up happening was that he loved playing cards. He loved playing solitaire, but in Russia at the time, it wasn't called solitaire, it was called patience. But either way, it was a card game that you played by yourself. And he was a chemist, and he became convinced that there was a pattern among the elements. So scientists knew about, a few dozen elements at the time. They didn't know about as many as they do now, but he was aware of many elements, and he figured, there must be some pattern to these elements. Their properties, right? It's not just random. When you're a scientist, you expect to look at the universe and see patterns and see order. So he figured there must be some pattern. And so what he did is he took all of the elements that he knew about and he wrote them down on cards. Right? He just wrote down stuff that he knew about them on cards. So, like, here's an example of a card that he might have made. He had the name of the element. So this is lithium. He also had the symbol for lithium, but then he also wrote down a couple of things that he knew about each element. He knew, for example, the mass of the element. He knew the mass was 6.94, but he also knew how many oxygen atoms that lithium tends to bond with. And so see here, you'll see that 2 lithiums tend to bond with 1 oxygen. And so he did this, but for every known element at the time. And what he did is he spent hours and hours and hours trying to arrange the cards in such a way that they just made sense. And the legend is that he fell asleep one night and he had a dream. And in the dream, he saw the correct way to put them together. In his dream, he arranged the cards in a certain way that it just everything made sense. It was almost beautiful to him how the dream went. And so he woke up from that and he started arranging the cards the way he had in the dream, and lo and behold, it worked. And so, but that's not the best thing about it, right? What he started doing is he started arranging them in order of the mass, right? So he arranged them so that the masses got bigger and bigger and bigger. Right? But then what he started noticing, and this is the great part about the periodic table, what he started noticing was that there were gaps in the cards. Right? He started realizing that when he arranged them based on their mass, that the columns, the elements that ended up in the same column as each other tended to have similar properties. Like, so for example, they tended to bond to a similar number of oxygens. Right? So, but when he arranged them this way, there were gaps. And what's great about this is that he did something that was pretty legendary. What he did is he was able to predict the properties of elements that had not yet been discovered. Right? He said, okay, there's a gap here. Nobody knows what element goes here. But when we discover it, it should have about this mass, and it should bond to this many oxygens. And after he died and even in his lifetime, scientists discovered new elements, and he was exactly right. He was exactly spot on. And today, we know what elements go inside of all of these gaps. And so that's what the periodic table is all about. That's why it's so useful. You can look at the columns and the rows, and you can use it to predict and to kind of generalize the properties of each element. Now, just a couple of basic things about the periodic table. When we talk about the columns, right? When we talk about the columns on the periodic table, like, this one right here, this one right here, these are called groups. Okay? These are called groups. So you need to know what I'm talking about if I say, hey, go to your periodic table and look at group 2. Or if I say, look at group 13, what do I mean? I mean, look at this column right here. Or if I say that silicon is in group 14, I'm talking about this column right here. Okay? So you cannot forget what we mean by groups. Groups mean columns. This is vital for you to understand. Now, periods are what we refer to as rows, right? So like this would be a period on the periodic table. So, but it's not as important that you remember what a period is, right? We talk about the rows on the periodic table sometimes, but far more often in this class, we're going to talk about the groups, the columns, because each individual group is very similar to one another in certain properties. All right, so that's the first thing to understand about the periodic table. The second thing to understand is just the 3 main categories of elements that we have. And actually, this periodic table has been posted to Google Classroom for you. This is now the periodic table that is available on Google Classroom for you to use. And so there's 3 main types of elements out there. Okay, the first type are the metals. And so most most elements on the periodic table are metals. They're the ones in the red box here. And just some general properties of metals. They are good conductors of heat and electricity, right? So what that means is that they let heat pass through them very easily. They let electricity pass through them very easily. So if you want to make an electrical wire, you're going to make it out of some sort of metal, like copper or gold or something like that, right? They're malleable, so what that means is that you can bend them and shape them into different shapes. Like think of someone who's making a sword, right? They're taking metal and they're banging it and heating it up and turning it into a certain shape, and that's what it means to be malleable. And metals typically are quite shiny. Not all of them, but they're typically quite shiny. Now, on the other hand, we have what are called nonmetals. And so the nonmetals are over here in the blue. They're things like nitrogen, oxygen, neon, chlorine, things like that. And these things are typically very bad conductors of heat and electricity compared to the metals. If they're in a solid form, they aren't really things that are malleable. They break easily. But the important thing to remember about nonmetals is that we are pretty much made up of nonmetals. These are also called organic elements or organic compounds or whatever, right? They're because they're in living things, right? Actually, most of your body, probably 99% of your body is carbon and hydrogen, right? And then the rest of it is oxygen and chlorine and stuff like that. Nitrogen too, stuff like that. So nonmetals are very important to understand, especially for biology next year. We're going to spend a lot of time in biology next year talking about carbon. But there is a group of elements that are kind of in between, and these are called metalloids. They're in the green here, and they are kind of found along this stair step here. All right, so metalloids can have properties of both metals and nonmetals. They can be good conductors of electricity, like look at aluminum here, but they could also be bad. Silicon, right, is considered a metalloid because it's on this border here. And silicon is a semiconductor. They use it in computers. So notice it's not a full-blown conductor, but it is a semiconductor. It's pretty good, right? Metalloids might behave, for example, they might behave like metals when they're very, very hot, but more like non-metals when they're cold or something like that, right? So just understand that metalloids are kind of in between here. That's all for this video. If you have any questions, be sure to email me or join me on Zoom. Those happen on Tuesdays and Thursdays from 11 to 11:30 a.m. See ya.